Hello, I am Christian Mullins and this is my 403 testing systems presentation. The machine that I am basing my testing system off is a 944 John Deere wheel loader. This machine only has 27 hours on it. The customer that owns this machine is Michigan Paving Materials / Stoneco. The customer complaint is that when accelerating from a stop, there is a feeling of hesitation and the operator feels excessive vibration. The vibration and hesitation will go away when the rate of acceleration is reduced. The customer also stated that the hesitation will feel like it is coming from the rear of the machine, sometimes in the front of the machine, others, and also alternating sides. The customer has purchased 4 944Ks this year, and each one of them are set up exactly the same. The machine that is located in Lansing is experiencing these problems. Customer interaction. The machine needs to be diagnosed and running as soon as possible. Since it is the largest machine on the plant and can load material into the bins more efficiently than their other loaders, cost is not a factor because they are not as productive without this machine running material. Proposal. Testing will be completed at the Lansing plant. I will first take an oil sample analysis of the major drive components: the transmission, right front drive, left front drive, right rear drive, and left rear drive. Oil analysis will be sent on high priority and the results will be received by the following day. The machine will be down until results come back. If the results of the main drive components show no signs of excessive internal breakdown, then the machine can be used if needed, and testing will resume after the operator is completed using the machine. The timeline for this testing system is as soon as possible. The customer would like to have the problem diagnosed and fixed within 1 week. To achieve this goal, the process of verifying the complaint and taking oil samples is completed on the first day. For the second day, I will use the vibration analyzer in the cab of the machine to receive readings that can be compared to the loader that is not showing any signs of vibration or hesitation in Grand Rapids. I will then have readings off both machines to compare. I will then, on day 3, use a slow motion camera to watch the drive shaft underneath the machine and simulate the complaint. The camera will also be used to watch each side of the machine while the complaint is simulated. Conclusion on the problem should be verified on day 3, and processes to fix the problem and complaint will take the remainder of the guideline if everything goes as planned. Tools needed to complete testing include 5 John Deere oil sample analysis kits, a FLIR Blackfly PoE Gig E slow motion camera, and a Fluke 810 vibration analyzer. After the complaint is verified, the first step that I will take in the testing process is an oil sample analysis. The results of the oil sample analysis taken after the complaint verified that there were no signs of excessive internal breakdown on any of the major drive components, verifying that the vibration and hesitation is not related to the transmission, right front drive, left front drive, right rear drive, or left rear drive. For the second step, using a specialty tool, I will use the Fluke 810 vibration analyzer. When using the analyzer, I will simulate the complaint and take a reading inside of the cab of the machine. This gives me the information off of the machine with the complaint. Once the measurement is saved into the analyzer, I will then go to Grand Rapids and compare the reading to the 944K that is located at their site that is set up the exact same. During this process, I simulated what caused the vibration and complaint on the exact same machine and setup on the loader that runs the plant in Grand Rapids. After completing the simulation, I found that the loader in Lansing does have more vibration inside of the cab, and that verifies that the operator is not comparing the difference between the smaller loaders that are located at the Lansing plant compared to the 944K, since he operates all loaders. Verifying that the vibration is excessive with the analyzer removes the assumption that the operator may not be familiar with the machine yet. The next process is using the FLIR Black Flag PoE Gig E slow motion camera on the loader that is located at the Lansing plant. While simulating the complaint, the first location the camera is watching is underneath the machine, looking at the drive shaft. After simulating the complaint with the camera in this location, watching the drive shaft in real time and both slow motion, I find that the drive shaft does not show any signs of excessive movement or play and is not causing the vibration/hesitation complaint. The second location the camera is placed is off to the right of the machine, allowing a view of both the front and rear wheels. When completing this, the hesitation of the machine feels like it is coming from the left rear of the machine. After watching the video playback of the machine, I noticed that there is no difference in movement between the wheels on the right side of the machine, and the rims and tires are moving at the same exact speed on the right side of the machine. This shows that the hesitation is not showing any signs on the right side of the machine during this simulation. I then move the camera to the left side of the machine and simulate the complaint. This time, it felt very obvious that the hesitation was coming from the left side of the machine. After watching the video playback of the left side of the machine in both real time and slow motion, it is noticeable that both the front and rear tires stopped in movement while the rims were moving at the same exact speed on both the front and rear tires and spun until the acceleration rate was decreased. This process allowed me to see that the left side of the machine was spinning on the bead during the time of the complaint. After reviewing all tests performed on the loader, I've concluded that the complaint is happening due to the tires spinning on the bead of the rim. The complaint varies since all four tires have a poor seal, and my assumption it also allows the hesitation to feel like it is coming from different sides of the machine since all tires are not spinning the bead at the same time, and it varies when the complaint is present. To repair the machine, since I do not have the materials to repair the seal and remount the tires on the machine, I call in the tire company that mounted these tires and have them complete the process. After the tire company mounted and resealed the tires, I go to verify that the complaint has been fixed. To do this, I put the machine under the same load and rate of acceleration that the problem was present before, still using the FLIR camera to watch the relation between the rims and tires. I find that the complaint is still present after the company mounted the tires and look at the video playback and see that the tire is still spinning on the rim. I then notice that the loader in Grand Rapids uses a different tire company that is located in between Lansing and Grand Rapids. Since the company that already, since we already used the company that is out of Lansing, and they could not stop the tire from spinning on the bead. I call the company that mounted the tires on the loader at the Grand Rapids plant to reseal and mount the tires onto the loader located at the Lansing plant. During this process, the tire company resealing the tires and mounting them, the technician mentions to me that these loaders need to use a high torque compatible sealant, otherwise the tires are suspect to spin the rim. They found this out with a different company that was having the same problem. After the tires were mounted and resealed, I once again go to verify that the complaint is fixed, simulating the process that causes tires to spin on the rim multiple times. After verifying that the complaint was fixed, I noted that the cause of the complaint was improper bead sealant used by the company located in Lansing, and let the customer know that a high torque bead sealant is required on these loaders for future reference, so that the problem does not happen again to any of these 4 machines. And that concludes my presentation.